All right, so question number 4, non-calculator question. The rest of these are non-calculator, 3, 4, 5, and 6. Deals with a cylinder. This is a related rate problem, straightforward related rate problem. The AP test bounces around. Sometimes they put these on, sometimes they don't. This year, again, with the weird testing schedule that it is, I have no idea. I wouldn't bank on this, but I could be wrong there. We'll see. So practicing this one. So first, we have the cylindrical barrel, 2 feet diameter, and the water is draining out. It's not shown the rate that the height is changing. DHDT is -1/10 radical h. H is measured in feet, T is measured in seconds, and they went ahead and gave you the volume of a cylinder. How kind are they? So part A, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. So they're telling you find the rate of change with respect to time. That means t is the variable, just like all our related rates are. To find that related rate, we have to take the derivative of our volume equation. But remember when we did these way back in first semester, back in December and November, anything that's constant, we can change into a number before we take the derivative. We can take the derivative right now. If we do that, we have pi times r squared times h. That's a product. That's going to require the product rule. However, if we have anything in there that's constant, we can change it to a number, and that might help our derivative a little bit. Turns out the radius is constant. It's a cylinder. So once that bottom layer of water is filled, as it fills up or as it drains out, that radius isn't going to change. Since we know that the diameter, they told us that the diameter is 2 feet right there, that means that the radius must be 1 foot. And so we can go ahead and put that into our volume equation right away before we even take a derivative. So now I have volume is equal to pi times h, because 1 squared is 1. Now I can go ahead and take the derivative and find the related rate. So when we do that derivative, dv dt, right, we're taking the derivative with respect to time. Pi is a constant, so it's just going to hang out and multiply the derivative of h, and the derivative of h is dh dt. None of these are 1 because time is our variable, not h, not v, not any other letter. From here, we just need to figure out the rate of change when the height is 4 feet. But I don't have dh dt. Oh, wait, yes, I do. DHDT is given to me right here. And so I can plug that into my equation. dv dt is going to equal pi times -1/10 radical h. We want to know the rate of change when the height is 4 feet. So all we need to do now is plug in that 4. So dv dt at 4 is going to be pi times -1/10 times the square root of 4. The square root of 4 is 2. 2 times -1/10 is -1/5. And so that's going to give us negative pi over 5. And then don't forget the units. It's dv dt. V would be volume measured in cubic feet. T is time. Time is measured in seconds. And so we have negative pi over 5 cubic feet per second. Nice and easy. So points for this problem. It's not much. You get 1 point for taking the derivative of the volume equation correctly, and then 1 point for your answer. That's 2 points that are pretty easy. We look at related rates and we think, oh my god, those are really scary, right? We had trouble with those, as we always do when we did related rates back in December, but it's not that bad. Once you take the derivative, once you realize that t is the variable, it's a very, very fast problem. Part B, not bad either. Part B, they're telling us that the height of the water is 3 feet. Is the rate of change of the height of the water increasing or decreasing? Okay, well, I know dh dt. That's the rate at which the height is changing. dh dt, once again, is -1/10 radical h. I'm going to write that as -1/10 h to the 1/2 power. That's the rate at which the height is changing. In part B, they're asking us, is the rate of change of the height of water increasing or decreasing? So is this rate increasing or decreasing? So what we need is we need to look at the derivative. So that's going to be the second derivative of the height. We'll write that as d squared h over dt squared. It's not squared, it's just the notation. When we do this derivative, no problem. That -1/10 is going to stay there. It's a constant multiple. That 1/2 power is going to cruise down in front, become a multiplier. It's going to multiply h, and then we have to subtract 1 from the power to make it -1/2. Now, you might stop there. But you can't stop there. This is implicit differentiation. T is still our variable, right? It's dt. And since t is still our variable, not only do we have to do that, but we then have to do the chain rule, and we have to multiply by the derivative of h. And the derivative of h is dh dt. So we have to tack on an extra dh dt here. Last year, many students forgot that part. Don't forget the chain rule. Once we get here, now we can just clean this all up. I have got negative 1/10 times 1/2 will become negative 1/20. We have h to the negative 1/2 power. And then we have times dh dt, and we know what dh dt is. They gave us dh dt. It's negative 1/10 times h to the 1/2 power. So if I continue to multiply all of that out now, negative 1/20 times negative 1/10 is positive 1/200. H to the negative 1/2 times h to the 1/2, that equals 1, because it's h to the 0 power, and so this is our second derivative. And so our second derivative is always going to be positive 1/200, so the rate is increasing because the second derivative of the rate is positive. That's all you got to say. You don't need to go into detail. You don't need to explain anything else. It's very quick, it's very short, it's very fast. Point totals for this problem. We've got 3 points coming in for this one. You get 1 point for taking the derivative correctly. In other words, making sure you get that dh dt in there. Lose that dh dt, you're not getting much, if anything, for this problem. You get 1 point for figuring out that the second derivative is 1/200th, and then you get 1 point for saying that the rate is increasing because the second derivative is positive. Finally, Part C. Part C is what we're going to be looking for on every single test. If this were a normal test, we would definitely have one of these. I am extremely confident that we will still have Part C. Now, how we have Part C could be different. In years past, we've had slope fields. In years past, we've had an equation. It hasn't been tied into a related rate until last year, but who cares? If we read Part C at time equals 0, the height of the water is 5 feet. I'm going to go ahead and write that down right away. At time equals 0, h is 5. And we want to use separation of variables. This is what we just got done practicing much recently. We need to knock this out of the park. I am confident that they're going to still keep this in on the test. I am confident that it's going to be there on one of these parts, so this is something that we definitely want to make sure that we have locked in. So we're going to take our derivative, dh dt, which equals negative 1/10 radical h, which again I'll write as h to the 1/2 power. And we need to separate those variables. We don't have any t, so we don't have to worry about that. We got to get h on the dh side, and then we got to move that dt. So I'm going to do two things at once. I'm going to multiply both sides by dt, and I'm going to divide by that h to the 1/2. When I divide by h to the 1/2, I'm going to write it as h to the negative 1/2. And so that'll be on this side with the dh. That negative 1/10 can go anywhere. It's just a constant. I'm going to leave it over here with the dt. Otherwise, dt would be lonely. We don't want dt to be lonely. There we go. Once I've got those variables separated, now I can go ahead and integrate both sides. So throwing that integral symbol over here and throwing the integral symbol over here, now we can go forward and integrate. On the left side, that's just a simple straightforward power rule. We'll add 1 to the power. Negative 1/2 plus 1 is positive 1/2. And then we'll divide by 1/2, which is the same thing as multiplying by 2. On the other side, that negative 1/10 is a constant, and so it just stays there. And the integral of that will become t, so negative 1/10 t. And then don't forget we have that super constant. Remember, that constant is taking care of the constant from both sides and putting it together to make one constant. Now we need to figure out what the constant is. We're going to use our initial condition that they gave us, the fact that at time equals 0, the height is 5. And so plugging in 0 and 5, we have 2 times 5 to the 1/2 power is going to be equal to negative 1/10 times 0 plus c. And so c ends up equaling, I'll write it with a radical, c ends up equaling to radical 5. Cool. Now that we've got c, we can finish this problem by figuring out what the h equation is. So plugging c back into my equation, 2 times h to the 1/2 power equals negative 1/10 t plus 2 radical 5. It's pretty straightforward from here to solve for h. We're going to have to divide everything by 2, and so that'll leave us with h to the 1/2 equals negative 1/20th, since we're dividing by 2, t plus just radical 5 now. And then finally we will square both sides to get that h is equal to the quantity negative 1/20th t plus radical 5 quantity squared. Hopefully you'll notice that there's only 4 points remaining. So as I mentioned earlier in class before we broke apart, that this is usually a 6 or 5 point problem. In this case, it ends up only being a 4 point problem. That's rare. Like I said, they never tied it into a related rate problem, and so their grading changed it just a little bit, but our point values are still coming from where we know they're going to come from. 1 point for separating the variables correctly. Usually you would get 1 point for integrating the left side and then another point for integrating the right side. That's not the case this time around. This time around you get 1 point for integrating both sides correctly. They may have done this because both integrals are super easy, and so they decided you only get 1 point, you shouldn't make an error on either side. You don't get a point for C this time around, but you do get a point for figuring out what C is. And then finally, you get a point for having a correct H equals equation. As long as you've got a correct H equals equation, you've got that 4th point. So when you look at this overall, it's not a bad problem. It looks scary. It looks intimidating. You've got that cylinder, a lot of words, but it's not. Don't let the way the problem is presented intimidate you. We can power through these problems. If you look, there's nothing here that's super scary. I would expect us to get most, if not all, of these points on this problem. So until next time, stay safe, and we'll see you soon.